Wow, that's a big crowd. I'm pretty excited to be here. Thanks for having me. Topic of this talk is going to be MySQL high availability solutions, and what I'd like to do is give you an overview of how you can make a MySQL server instance more robust and more more available if some of the systems go down. Let me start with a quick introduction of myself. My first contact with open source software was in 1995 during my studies in the university. This is where I first learned about Linux and all the exciting things that you can do with it. I've been using Linux on my desktop exclusively since then, which kind of led me to working for a company that is related with Linux. I was a distribution engineer at SUSE from 1998 until 2002. That was before they got acquired by Novell. One of my first tasks there was to add MySQL to the distribution that didn't exist before. Back then, MySQL was not available under the GPL. They still had their own homegrown or homebrew license, which basically made it impossible to include it on the distribution based on the terms they have set up. So I got in contact with these guys, Monty and David, the founders of the company. We exchanged some email, and I kind of asked them, okay, what can we do to get MySQL on SUSE Linux, since I really wanted to have it on there. And the deal that we struck over email was that SUSE is allowed to include MySQL, and in return we sent them 5 packaged boxes of the distribution each time we make a new release. So that was a pretty cool deal. And so since then, MySQL is available on this distribution. Actually, SUSE was the first of the Linux distributors that shipped MySQL as part of their package. So I've been in contact with these guys very early on, which, we stayed in contact every time there was a new release. We were talking about what needs to be fixed. I met Monty and David at numerous conferences all across the world. They were giving talks about MySQL. I was giving talks about SUSE Linux, so we bumped into each other quite a lot. And during some random email discussion, I kind of jokingly asked if they would have a need for a guy like me, and boom, 2 months later I joined MySQL as a release engineer. So my first task was offloading Monty from the task of building the MySQL releases. So the developers were hiking on the code, and at some point it was time to make a new release. And then when I got into gear, I started the builds, compiling MySQL on all the various platforms, doing the packaging, publishing and uploading these things, sending out the release announcements. All these things that relate to release engineering were in my lab back then. I also started getting engaged with the MySQL community on our mailing list and all the other available forums that we had. So at some point I realized that this is what I'd like to do more, and I went to doing community relations exclusively, and this is what I still do. Back when we were an independent company, the community relations team actually reported to Martin Mickos, the CEO, directly. So it was always a very important role inside of the company. So we didn't report to marketing or were part of engineering. We really were independent from all of these groups, sometimes even with a different agenda, especially with marketing. And we, of course, had contact with all these groups. As the community team, you really have to pull strings into all these various directions. You get feedback from the users, from your community, that you have to then trickle into the engineering organization to let them know what needs to be fixed, what the focus of the product should be. You talk with the marketing folks about how the messaging to the community should look like. Product management needs to be advised on how the community expects things to be done. So it's a very exciting job, and I still enjoy doing it, even though I've switched companies 2 times in the meanwhile. You probably all know the story of MySQL and how we got acquired by Sun, and how Sun in turn got acquired by Oracle. So I'm now an Oracle employee by business card, and, well, kind of still a MySQLer by heart, I guess. So this is who I am. I'm here in the Bay Area for the same event that Sarah was talking about, the IOUC Summit, as in my role as the MySQL community relations contact for the EMEA region. So this meeting was really a meetup of all the leaders and presidents of Oracle user groups worldwide, not just the US. And what struck me as very interesting is that all of these Oracle user groups do have a lot of interest in MySQL. Their users and the members already use MySQL somewhere in their data centers already. And now that that MySQL is part of Oracle, they are not shy anymore to actually talk about it. So in a way, MySQL has become a bit more serious with this corporate backing. And as it's probably obvious with the latest release of MySQL.5, Oracle is not out to kill MySQL in any way, quite the contrary. MySQL definitely change and mature over time. This is what a big company brings with it. And I think some of these changes are certainly for the better. I mean, a small startup has different focus and different requirements for a product than a company like Oracle, who definitely realized that MySQL is not competing with a big database. MySQL serves a completely different need and audience, and this is where MySQL is going to be improved for in the future. So we're not trying to become a replacement or a competition to the Oracle database, but we are going to make sure that MySQL will continue to be better for the use case that you are using it for. And so we are now much better suited to really address the needs and the requirements of where MySQL is being used today. That said, let me give you a short agenda. I start with a little background about MySQL high availability concepts. Then I'll try to introduce the various building blocks of what you should take a look at if you want to create a high available MySQL setup. And this is an introductory talk. I'm not going to go into the gory details on how to actually set this up. Each of these components are quite complex, with the exception of MySQL replication maybe. So it also requires that you have to look into what your particular needs are. High availability usually isn't something that you can get off the shelf and it suits your needs. You have to really customize it and make sure it fits your personal requirements and what you need to get configured in your system. MySQL cluster, pacemaker, all these are tools that I'm going to talk about. So let's take a look at what you probably know. So we have a server here, a PC. You have MySQL running over there. You have your local hard disk drive. And your client, either your web app or an external application, it talks to the MySQL server using SQL statements. These can come either through the wire, so over TCP/IP, or even on a local socket coming from the same machine. The MySQL server takes your statements and performs the required action and then stores the data on disk on your file system and returns the result sets to you. So what happens if this machine crashes? Well, you're screwed. You don't have any replacement, you don't have any backup. The client can't talk to the server anymore. So something needs to be done about that, particularly if that client is a web app that serves 100,000 people that are waiting to get their order placed into a form. So why do I need high availability or HA? What you can really be sure of, something can and it will fail at some point. And according to Murphy, it will always fail in the time that you're not expecting it to be. And well, if you're a web shop, there isn't really an ideal time because somewhere over the globe somebody is awake and wants to do a purchase. So downtime is usually not an option. But it's not only necessary to avoid grave failures in hardware or software. Sometimes you just want to be able to make an update of the operating system, or there's a security problem with MySQL, you need to update. So for service maintenance, you need to be able to have a way to keep your system up and running, but still be able to perform such maintenance tasks. And yes, I've already mentioned it, downtime is expensive, and depending on the role in your company, you either get fired or you go bankrupt if something like this happens. So keep it in mind, downtime can be significant. And also, if you are just starting from scratch and you're building up your infrastructure and you're working on developing a new system, try to consider high availability as part of your entire setup from the very beginning. It's usually quite painful to add this to an already existing and running system without introducing any downtime. If you start with having high availability in mind from the beginning, you're much better off than trying to plump this in at a later point in time. So the aim of high availability is to eliminate the so-called SPOF, the single point of failure. So, and the single point of failure can be quite a wide range of things. Things that definitely fail at some point is everything that is moving and spinning, like hard disk fans, spinning rust, like hard disks. They have a mean time between failures. And especially under extreme circumstances like high temperature, these end-of-life situations tend to get reached much faster than you think. CPU fans are always cheap or too cheap, and they start to fail. But not always hardware can fail. Your application can crash. There's a bug, and one of the services goes down, and your website still fails and is not reachable. Linux, for example, has this nice tendency to completely come to a grinding halt when you run out of memory. Or if you go heavily into swap, all of a sudden your system is so busy with itself that it's not servicing any request anymore. And the only solution for that usually is you have to reboot. If you can still shut down, enter the shutdown command. Linux can really get itself into a state where it's not reacting to anything anymore. And in that case, you just have to flip the switch, which then might lead to other problems and you want to get back up on your feet again. Other operating systems handle this a bit more gracefully. Or, well, the classical case that the cleaner trips over the cable and the network cable of your server is out. No connection. What happens? Power supplies are always good for fun. So there are lots of sources that can become the single point of failure that you should take a look at and need to have or need to be aware of. And this really is something that only you can identify. You have to go through your configuration, your system, your environment, and take a look at, okay, where are the crucial parts? Which are the things where I might want to have a replacement somewhere on the shelf, or even better in a hot standby mode, ready to be acting as the replacement for the active system. And with computers and servers, what you usually do is you create a cluster. A high available cluster means you provide redundancy of hardware and the data that you want to store in it. In that case, you have a backup system or more of them that can take over in case that your primary system goes down. In the case that I'm talking about, what you usually do is you have a so-called virtual IP address. This is the IP address that is known to the other services and applications to talk with this particular server. But this virtual IP address can move between different physical hardware machines. So the application doesn't really care. It's always talking to the same IP address, and it doesn't realize that the hardware and the system behind it has been replaced because the original one went down in the meanwhile. And yeah, you have to ensure that the data that you want to make available is also in an integer state, or is is not corrupted by the failover or by the failure that has occurred. And even though it's tempting, a high availability cluster is not designed to replace any performance tuning measurements that you might want to also make. So a high available HA cluster is something different from a high performance cluster. Sometimes you can use it for both purposes, but something that you have to keep in mind, if you design your system that two machines are constantly serving your load, because, well, who wants to have a system just being there running idle? We can make use of this because we currently have such a spike in load. Let's use the hot spare for this. Cool. And then the primary system fails, and all of a sudden the load that you've gotten used to had to be served from that single remaining box. And then you run into the next problem because it will get saturated and fall on its feet or over its feet. So high availability and scale out are two different things, and both need to be kept in consideration, of course. You probably have seen this slide before, if my clicker works. The level of availability is usually given in a percentage, uptime per year, and the magical 5 nines is when you have only around 5 minutes of downtime per year. And that little curve here also shows the cost that is usually involved with getting there. So the question that you should be asking yourself, do I need 5 nines? Or is it fine if my system is available for, well, at least less than an hour per year? Does it make sense? No, or can it go down for less than an hour per year? Sorry. So you want to get an explanation of the difference between high availability and high performance?
Yeah, if you repeat exactly what
Sure.
you say, I cannot get a lot.
Okay, consider that you have a system that you want to make highly available. In order to do this, you need redundancy, maybe in the case of a second server. So your application runs on your primary server. The second server is a hot standby. It's doing nothing because it just waits for the case that the primary goes down and then it takes over. So it makes sure that the data is always being synchronized and it's ready to start at any time. Then your boss comes in and says, hey, our website is getting so much load. We need more power. Isn't there this second box? Can't we use that to serve some parts of the load? So you enable the second box and you start serving requests from there. So now your application is distributed on 2 machines and the load goes down. Cool. And then the primary node crashes. So all of a sudden, the load from this service and the additional load that you have put on the other box goes to one system. Yeah, that could be doable. So you could say, yes, we are using both systems, but we're just utilizing them to 50% each. But where's the difference, 2 times 50% to 1 times 100%? Yeah, you might get away with it, sure. All I'm trying to say is don't assume that your high availability system should be serving for the load distribution or to increase the performance. This should really be done on dedicated machines that can also be replaced with failover mechanisms.
Right. So
Rules of high availability. I put these in front. I usually had this as the last slide, and then I realized I run out of time and this slide never shows up. So I start with it here. Again, prepare for failure. It will happen at some point. If your service is valuable and you depend on it, make sure that it's always up or that you can provide at least a reduced level of service and you're not completely offline in any case. And also try to identify what is really important that needs to be available. Is it the entire website with everything, just parts of it? Most of the really popular websites usually degrade in a graceful way so that parts of the service is still available. Let's say you have a video or a picture uploading site. The part that still serves pictures is still up, but the part where you upload pictures might be down for a moment because this part just has a downtime. So try to identify if you have any options for implementing it in this direction in order to not having to make everything fully redundant. And yeah, keep it simple, stupid. The case of a downtime when something has crashed is usually when you have the highest stress and you need to get your system up and running as fast as possible. If you first have to read a 50-page manual to follow up and figure out how the system gets back up, this is likely going to cause you a lot of stress. So make sure to keep it easy and simple. And it's tempting to start adding everything to the high availability system. Hey, the mail server, cool, let's put it into in here as well. And the file server, yeah, we want to make sure that this is highly available too. So you have a very complex setup that all of a sudden serves way too many purposes and it's hard to figure out what happened. Or the administrator is on vacation or has left the company. So the more complex the system is, the harder it really is to get it up on its feet in case there is a failure. And also, as much as possible, automate this whole thing, create scripts, reduce the manual intervention as much as you can to make sure it's repeatable and has been tested. So the last part really is the most important one. There's no point in setting something up that is highly available that you haven't tested at all because you just trust, yeah, it'll work. Also, if you have made changes to the system, test if it still fails over. If you have installed a new package, if you have made it an upgrade of something, it may have changed something underneath that you're not aware of. Maybe the system doesn't boot up anymore. So even though there's always a little risk involved, the more testing you do, the less harmful is the fire drill. If it really goes down and it doesn't come back up again. Because then it's under your control. You're in front of the system. You can make the change. You can see if it comes back up properly or not. Murphy strikes again. Usually, if a failure occurs, you're not around because you're just asleep. It's 4 a.m. and then you're back in the data center, half asleep, and the system doesn't come up because you made a mistake. So that's something to avoid if you tested it before. Parts of an HA system. Heartbeat. That's the process or the application that kind of pings a service or an application or an entire system if it's still alive. Or several systems talk to each other and ensure that they're all still available, that the data that they are returning makes sense and it's not garbage. These things are usually done through some kind of heart beating system. You can either create this by yourself. The easiest way to check if a web server is up, you create a little shell script that runs wget for a web page, and you compare the content of that web page with a checksum or something like that. So you can check both that the system is actually answering and that what it returns still makes sense. Okay, in case that the heartbeat tells you that something is not answering or gives you wrong results, you need to take action. This part is usually being taken care of by an HA monitor application or tool. It makes sure that it takes the appropriate action to remedy the situation, either by just restarting a service if it's just a process that has crashed, or by switching over to a completely different system, making sure that the services are being started and initialized in the appropriate way. And I'm going to give you an introduction to the most popular tool here in a later slide. And also, it should be able to manually control these things, especially if you want to test this. There should be a console where you can run commands to do the failover in a manual way as well. So we're talking a lot about how to make the system and the services highly available, but something that's very crucial about it is actually the data that you work with. So if you have a mail server, the actual email or the mailboxes of your users, this is the important data. And in our case with MySQL, of course, it's the databases and table that you want to make sure remain up to date and accessible. So there are several ways on how you can make sure that the data is available or is being made redundant, and I'm going to talk about the two most popular solutions in the MySQL field here. Another term that pops up quite frequently is split brain. This is the situation in which you have two systems, well, or more, depending on your setup, that both think that they are now in charge of the entire application because they can't reach the other one anymore. So if you have two systems and they have a heartbeat going on and they check each other if they are still alive, and all of a sudden the connection between these two machines is down, they are still both up and running, but they can't reach their partner anymore. So they assume, okay, the other one is gone, I'm now the one to take charge of the application. And depending on how your system is configured, this may lead to really, really bad things, especially if you have a shared storage and you have two MySQL servers that now want to access the same table files. Bad. So in order to avoid this, you need to have a moderator or an arbitrator, which is usually a process or a server that runs somewhere outside that can kind of make the decision for these two guys if they can't figure it out by themselves. And then depending on what you use, this moderator takes some very serious action by simply shutting off one of the systems to make sure they can't create any more harm, or he runs scripts or executes any certain commands to make sure to solve the situation. This depends on how it's being configured and what tools you use. But split brain is something to avoid as the plague. Okay, I'm now going to talk a bit how to make the data redundant. And the first thing I'm going to talk about is what's built into MySQL replication. You're probably all aware of it, I hope. So what we do, this is the setup that we just have. We have our server with the local hard disk running MySQL, and we just pop a second box right next to it. In this case, it's also running MySQL with a local hard disk. The client is configured to talk to this box as usual, which then stores the data on its local disk, but also replicates the data to the second MySQL instance. So you now have a backup copy of your data sitting on a second machine, ready for you to be used in case it's needed. So the data is stored here as well, and in case this one falls down, your application just talks with the second copy, which is still there. And the usual way to do this is by using what I already mentioned, a floating IP address. So the MySQL client application appears being configured to talk to a virtual IP address, which is then moved over to the second machine by either a script that you've created yourself or using a load balancer or one of the tools that are available. So a bit more details about MySQL replication. I hope I don't bore you with this. MySQL replication is built into MySQL since 3.23. It has been around for quite a while. It's a way to replicate statements that changed data in your table. So you need to have a second copy of the data that is in the same state, and the replication then copies over all of the statements that modify data in any way, so the changes are being applied on both sides. It used to be statement-based, so we actually distributed the SQL statements that are used to change the data. Since MySQL 5.1, you can also use so-called row-based replication, in which case the actual changed data is being copied over to the other side. It's fairly easy to configure and set up.
There's a mixed mode, isn't there?
There's also a mixed mode, yes, good point. So in the mixed mode, MySQL decides if it's going to use statement or row-based replication based on what makes more sense in this situation. One thing to keep in mind, MySQL replication by default is asynchronous, which means that the MySQL master server doesn't really know or care if any of the slaves has reached and replicated the data. It just proceeds and goes on. It's actually not aware of the slaves at all, so it's up to the slave to make sure that it's keeping up with what's happening on the master. We have added a new feature in MySQL 5.5, which is called the semi-synchronous replication, since it's not fully synchronous. It's a nice workaround that we have implemented there. What we basically do is that the MySQL master server waits until at least one of the slaves has acknowledged that it has received the data on its side. So there is a backup copy somewhere outside of the master server before it proceeds with giving the OK to the application. So on the master server, you have a so-called binary log file, and this is where all the statements, all the rows are being stored. The slave then connects to the master and just pulls everything that has been put into the binary log since the last time it has connected to the master. So MySQL replication is pull. The slave connects to the master and pulls the data from there. It's not the master that says, hey, I've got something new, here it is. The master just writes it to its log files and forgets about it. The slave goes to the master and asks, okay, do you have anything new for me? And then it grabs all the changes since then. A little caveat here is that replication on the slave is single-threaded. So while on the master you can have multi-concurrent sessions banging on the server at the same time, on the slave all these changes are being serialized and being applied one after another, not in a parallel fashion as it happens on the master. So the slave may lag behind if you have really quite a lot of updates happening. So if you are very heavy on I/O, your replication slave might actually have to be a bit faster than the master in order to keep up with what's happening. We are working on how to solve this problem. Right now, what you are thinking of is having separate threads for separate tables. Not at the moment. MySQL isn't designed like that. But we are aware of this limitation, and the link here gives you a bit of background information how we try to solve this problem. Just to repeat for the remote audience, one of the problems is that the replication used to be statement-based, and since if you want to treat transactions in the appropriate way, you simply have to serialize this to make sure that the data ends up in the right order and is consistent. One thing also to keep in mind, this is just pure data replication. There's no heartbeating, there's no monitoring or nothing. It's to be implemented outside of the MySQL server. Something that we've added with MySQL 5.5 is a so-called replication heartbeat. So this allows the slave to determine if the master is actually still up or if it has failed, which can be then used with external scripts to take appropriate action if the heartbeat is missing. And here's a quick overview on how replication is being configured. So you have the MySQL server here. It writes the data to its local tables, and also all the changes are being stored into the binary log. The slave then connects and replicates the data. And the first thing the slave does is storing the data in its own log file, the relay log. So all the changes, they don't end up in the slave's tables directly. They are put into a temporary space, so to say, the relay log. And from there, the SQL thread is taking all the updates, it inserts and deletes and applies them to the local tables. Okay, I'm not going to this in much detail, but both statement-based and row-based replications have their pros and cons. I will make the slides available for you to download, so I guess we can skip this for now. It would take a bit too long. So row-based replication was included or added in MySQL 5.1. And this is the replication technology that usually is used by all the other classical database systems. So statement-based replication was pretty unique to MySQL. There weren't really only a few other databases that implemented this approach. There are several ways in how you can set up MySQL replication. The simplest one is you have one master and one slave. A master can also have multiple slaves that take the same data and replicate it. It can be cascaded in this fashion. This makes sense if you have, for example, quite a lot of replication slaves that would add too much load on your primary master. So you can set up one slave that then serves just as a master for all the others to offload the system from this task. What's currently not possible is that you have multi-source replication or multi-master replication where you have several MySQL masters that all replicate into the one single slave. Will this be coming eventually? We have lots of requests for that. I'm sure there's a work log entry for this. MySQL keeps track of all the features and things that we need to fix in a so-called work log, which is our internal tool for planning the releases. I would have to look it up if it's already being worked on and how far the implementation has gone. Yes, we do have a public copy of our work log on the MySQL Forge, forgemysql.com/worklog, if you want to take a look at what our engineers are up to. This is a very special setup that I'm going to explain in more detail later on, master-master. So you have two servers that are both master and slave to each other, and this can be quite useful. You can also create a ring where you have boxes replicating each other until the replication goes back to the beginning. That's also possible and has some use cases, but these two setups have their gotchas that you need to be aware of. Okay, elaborating on master-master. So you have two machines, both are from a MySQL standpoint configured to be master and slave of each other, which makes it quite easy to fail over because they are already aware of their relationship with each other. You don't have to reconfigure anything if a slave all of a sudden becomes the master because the other system crashes. It's already properly configured. So it looks like this is very tempting to simply spread write load between those two machines as well. It's master-master, right? You can just shoot queries at both of them. Doesn't really help because people sometimes assume that this gives them load balancing or helps them to distribute the write load. But since they are replicating from each other anyway, they also have to apply the same changes on the other side. That, and if one of the systems fails, since the replication is asynchronous, you don't really know if the data has already made it to the other side. So you're definitely going to run into inconsistencies that are hard to resolve. So if you are setting up a master-master MySQL setup, make sure that any queries that modify your data, insert, update, delete, are only sent to one of these nodes at a time. Right, so for schema changes, this setup has an advantage because you can make the schema change on the replication slave without any outage. But that depends on the schema change. If you just add another column, this works. But sometimes schema changes are not replicatable anymore. So depends. Sometimes you get lucky with this, but you definitely need to know what you're doing. DDL is also replicated, yes. So creating tables, dropping tables also replicates to the slave. And that's something to keep in mind. If you accidentally drop a table, it's quickly gone on the slave as well. So we do have a patch in the pipeline that will implement delayed replication, where you can set up the slave that is deliberately lagging behind the master for a given amount of time, which is a nice way to stage replication to avoid accidental errors like this, where you know, okay, I just made a mistake, but fortunately this slave is lagging behind, it hasn't received this statement yet, and it allows you to recover from there. So MySQL replication as an HA solution. What happens if the master fails? Well, the application won't work anymore, right? And the slave has nothing to replicate from. What happens if the slave fails? Data will no longer be replicated, but the application still runs fine on the master. And is this high availability? Yes? No, this doesn't sound like high availability. Right. Fooled by my own slides. Damn. Anyway, so replication is just a part of an HA configuration. So replication by design is pretty dumb. So it does its thing, it replicates data, makes sure you have a copy. But in order to use it in a high availability system, you need to do some more work. And if you're running Linux, which you probably should when you're running MySQL in production, you should take a look at Pacemaker, formerly known as Heartbeat. This Pacemaker is kind of the second generation of this tool. And it's an open source project that provides a framework for making basically any generic Linux service highly available. So it provides services that allow you to monitor resources like processes or hardware. It has the heart beating functionality. It provides a fencing mechanism. Fencing is the approach that you want to make sure that once a system is failing or is in an undefined state, that it doesn't interfere anymore. So the approach that they are using is called Stonith, shoot the other node in the head. And they usually do this by flipping a switch and taking off the power from the box. There are power strips that have a TCP/IP or a serial interface, so you can control them by PC in order to switch off the power, so the system in question is being shut off. It's pretty fast in determining if a service or a node has failed, and it can then take the appropriate action to do the failover to the backup system. And for MySQL, it even includes predefined scripts that automate this process, making sure that the master-slave configuration is being changed appropriately. It's quite complex to set up, but it has good docs. And there are even two examples that you can't really read on these slides, I guess. How to create a load-balanced MySQL replication cluster and how to use DRBD with MySQL. And DRBD is something that I'm going to talk about. So we have replication, we have Pacemaker. These two pieces combined give us a quite well-working high availability solution. So yeah, Pacemaker also uses virtual IP address that can float between systems. So I set up, in the minimal case, two MySQL servers that replicate to each other. We have a virtual IP address that is being used for the application to talk with one of these servers. And Pacemaker makes sure that if the MySQL process dies or the hardware fails, the other takes over and everything is being configured appropriately. The problem with MySQL replication is one that it's asynchronous. So in a case of a failover, there might be a gap and data is lost because it hasn't replicated before the master crashed or disappeared, whatever. And once the primary system is back up, you can't easily fall back to it because of the way replication works. So you have to figure out, okay, Is anything missing? Can I simply continue the replication with what has happened on the new master since then, or do I have to restore from backup? So failing from the master to the slave is usually easy, but going back again may require some manual interaction, since there is no automatic conflict resolution. And therefore, yeah, you need to invest some time or brain to get this sorted out. Okay, we can use other replication technologies, and disk replication is another one I'm wanting to cover. So in this case, we again have our MySQL server, which stores its data on disk. We have another one, and this time we just have a disk in there running at the moment. Application talks with MySQL on this side, stores the data on disk, and in this case, the replication is being done on the disk level. We're not using MySQL replication here, but we are replicating the files as they are stored on the disk by the MySQL server. And in case that the first one goes down, we start MySQL on the second system and have access to the file system and can start serving data from there. That process is not automatic. The switch over here would have to be done with something like Pacemaker, for example.
But you need a person involved to switch that?
Well, in the very basic case, this could be a DBA, yes. Yeah. But you usually have a script or something like that, or you use Pacemaker or a dedicated solution that takes care of this. If you're running Linux, we have a kernel module named DRBD, the Distributed Replicated Block Device. And what DRBD does is, yeah, well, it can be compared with RAID 1 over a network card. So you have a partition or a block device on the primary server, and then you set up a second machine, ideally configured in a similar way, also with the partition, and you enable DRBD on both systems. And DRBD will replicate blocks from one device to another with dedicated network card. And it's doing this in a synchronous way, which is very essential. So every time you make a change on the primary system, every block that has changed on this block device is being replicated over to the other side. And only when the second node acknowledges that it has received the block, then DRBD gives back the OK that then trickles up from the file system layer up to the application. By default, they are being configured in an active-passive configuration. Let me go back to that slide real quick. So you have the active system, and the replication takes place. And the block device on often the secondary system is not accessible. Even though you have a full identical copy of the data, as long as this one is in replication mode, you can't really access it. Well, DRBD has changed this in the meanwhile. So there now are options of doing this using a cluster file system, but by default, with the usual file systems like XFS or AXT, you wouldn't be able to access the data since DRBD works on a block device layer, so it's a layer underneath the file system. And file systems usually don't cope well with blocks that are changing underneath them when they are mounted. They don't expect this to happen, so you will run into grave inconsistencies if you try to mount such a file system. In fact, DRBD protects you. You can't mount a DRBD-controlled file system as long as it's in passive replication. You can put them both in active mode, yes. DRBD will complain about this, and if you don't have a cluster file system like OCFS or GFS, you will corrupt your data. Yeah, well, but be aware that this is not recommended. So only if the primary node crashes, the secondary will be promoted to be the new primary, and then you can mount the file system, start the MySQL server, and get going again. All right, let's see. Yeah, I mentioned this here. Dual primary mode is available. drbd.org is the website. The whole thing is maintained by an Austrian company named Linbit, and they have been very actively developing this thing for many, many years. And I think sometime last year, Linus Torvalds finally accepted the code, and it's now part of the mainline Linux kernel. replicates blocks. We already said that. Yes, and DRBD is very commonly used in combination with Pacemaker, for example, because, well, since it's on the block level layer, you can replicate anything, be it mail server or file server data, MySQL tables. It's used for anything. That's true. So since it's synchronous replication, and an RM minus RF star on the left side replicates immediately to the other side. So in this case, a backup is needed. Since this is happening, again, on the block level layer, when you fail over, you mount the file system, and the file system usually quite likely is in an inconsistent state first because, well, it's not a file system replication, it's a block replication. So this secondary starts up, you mount the file system, and first has to perform an integrity check. That's why you have to use a journaling file system like XFS, RiserFS, ext4, JFS. There are many options. But don't use ext2 or anything else that is not journaling. And then you have a file system. Then you start MySQL. If you use InnoDB, which you should, because my ISAM is not that robust for such situations, InnoDB will have to perform its log recovery and consistency check, and then you finally get going again. There were several questions. Let's start with this one in the back. So the question was how much latency is involved by this replication because it's synchronous, and what happens if the slave crashes. The terms that you've just been using make it sound as if you think this is a database, but it's just really block replication. There's no transactions involved. But it's synchronous, and in the way DRBD works is that the application writes to the file system writes into the block device, DRBD replicates this block over to the secondary node. The secondary node gives a confirmation that it has stored the block on its local disk. Then the primary confirms the file system, the block has written to disk, the file system informs the application that the data is there. So there is latency involved, yes, and therefore you need to make sure that for DRBD you have a low latency, high bandwidth connection between those two. So gigabit Ethernet switched or a crossover cable between two network cards is probably the best. And the second is what happens if the secondary replication node fails. Basically nothing. DRBD continues to run just fine on the primary node. It stores the data locally, of course. And it also confirms to the application immediately that the data has been stored, but DRBD is able to trigger a warning, or you have to take action in this point, and there are hooks in DRBD that allow you to do that. Once the secondary node is back up again, it will catch up. The master takes care of what has changed in the meanwhile. So once the secondary node is up again, it will simply take everything that has been changed since then. So it'll be in asynchronous mode for a while until it has fully caught up, and then it will switch back to synchronous mode. A DRBD can also be configured in asynchronous mode. So if you think that you can live with data loss and you are more concerned about getting a quick reply to the application, DRBD can also be configured to run in asynchronous mode, but that kind of defeats the purpose. And yes, for DRBD, you definitely want to use InnoDB tables and not MyISAM tables, because InnoDB is simply much more robust against corruption. And yeah, since we're replicating blocks again, you never know in what state the file system or the MyISAM tables are on disk in case you have to fail over. MyISAM takes just too long to get back in a consistent state. The MySQL system tables, yes, they are in MyISAM by default, that's true. The fortunate thing about the system tables is that they usually don't change that much. So the risk that you have a crash in the moment where you create a grant for a new user or something like that is relatively low. These tables aren't that hot like the rest of your data. So the chances are pretty high that they will be recovered just fine. Yes, you can definitely compare to this. So since DRBD is synchronous and creates a one-to-one copy of your data, it's basically similar to having a SAN or some other shared storage that you use, because you have just one MySQL server accessing the data at the same time, and then you flip over. And in fact, speaking of that, let me continue. This is how you would use MySQL using a shared storage system like a SAN or something like that. So in this case, we have 3 PCs or servers, and this one just runs the MySQL server. Again, the client just talks with this one using a virtual IP address, and the data is then stored on the central storage system using Fiber Channel, what have not, or Amazon, whatever is available. In case this one fails, you start MySQL on the second node, and it will then mount the file system and access the tables on that shared storage system. That's another option. Either you have 2 disks in both machines using the RBD to make sure they are in sync, or you have a central storage. But this central piece of storage may then be another single point of failure you have to consider in your analysis. And I have a bit more of a comparison and a few aspects here. So data consistency and integrity, especially with a shared storage or DRBD, since it's synchronously replicated or it's just stored one time anyway, if your data is corrupted because of the failure, it will be corrupted regardless where you fail over to. The second instance starts up and tries to access the data. If it's garbage and you're screwed. So MySQL replication in that case might have an edge because the data is really being duplicated to a second system, and a corruption on the file system level can't easily propagate to the next box. The sign can become the SPOF. Cold caches are a really nasty thing. In any case where you have to start MySQL from scratch and mount the tables means that, well, the caches are cold. You have just started the MySQL server. So you will have to live with in a certain amount of time where the performance isn't optimal yet. That's probably hard to avoid. With MySQL replication, the caches are already in a somewhat warm state simply by the fact that the replication is going on. And there are tools, there's a script included in MatKit that you can use to run queries based on the data that is being replicated that make sure that even more information is stored in the caches, which make a failover a bit more faster. Yes, using InnoDB was already said. Let me see, split brain. Yeah, split brain can usually just happen in this setup. If you by accident start 2 MySQL instances accessing the same data, you are host. MySQL isn't designed for that. Even though some people say, yeah, but I can put my ISAM in read-only mode. Yeah, you might, but is this a classical scenario? Probably not. And we don't really have any protection against this, so make sure it doesn't happen. Okay, MySQL cluster is the next one in my list. Who of you has heard of MySQL cluster? Using it? A few hands, excellent. Good. So MySQL cluster is a very interesting beast. Even though it's called MySQL cluster, it's basically independent from the MySQL server and can actually be used independently as well. So I have my MySQL D process running on one box. And then here, this is my cluster. In this case, I have 4 machines. The MySQL server talks to a MySQL cluster as if it is a storage engine. So instead of storing the data locally, like in my ISAM or InnoDB, any table that I create is being created over the network in a cluster of machines, which are these 4 down here, for example. I can also use 2 or 8 or what have not. And these guys here take care of distributing and replicating the data in a fashion that makes sure that failure can be tolerated. And the MySQL server doesn't really know about this. It just talks as if it was a regular storage engine. My application isn't aware of it because it just talks to a regular MySQL server. So in this case, insert, update, delete, go to MySQL client server protocol, and then the server puts the data into the cluster nodes, and they will then take care of the communication and the distribution of the data for me. I can also take a second MySQL server and connect it to the same cluster, and an update, insert, delete that I make on this side is automatically visible on the other side as well. So since the data nodes in the MySQL cluster replicate information synchronously, changes are automatically visible on both sides of the MySQL servers. And you can have more than 2 MySQL server instances. So this is pretty nifty because it allows you, if that one crashes, I would simply talk to the other MySQL server that's still available. If that one goes down, I don't even notice because the data is replicated to the other nodes and they take care of serving the missing pieces from another node. Of course, well, the administrator gets notified that the cluster is running in degraded mode and needs to take action. But this all happens automatically without any interaction. This is part of the built-in cluster. How would the monitor know which database to use? Okay, up here? Right. Again, this is something that you would have to do or have to script with something like Pacemaker or a load balancer or something like that. So informing the client application that it needs to talk to another MySQL server follows the same approach that I've introduced already. MySQL cluster just takes care of the redundancy part down here. How would you assess the availability? We claim that MySQL cluster gives you 5 nines. 4 nodes is a very common setup. Depends, of course, on the quality of your hardware. But it's a very robust system. MySQL cluster comes from the telecommunication industry. Back when MySQL was still an independent company, we acquired another company named Alzato. They were a spin-off from Ericsson, a big telecommunications company in Sweden, I think. And they created this thing called NDB, the network database, as a product aimed for the telecommunications industry. Ericsson uses NDB in their, I don't know how you call this, the call registers, I think it's called, so parts of the mobile phone network that take care that mobile phones are being registered, that calls are being distributed, and that everything is being built appropriately. So you have lots of high concurrency, very short running transactions with high volume. This is where MySQL cluster or NDB really shines. And well, we acquired the company and then we realized that it's very easy to make this into a storage engine. But you don't have to talk the MySQL client server protocol actually. I'm going to show this in another slide. These are commodity off-the-shelf Linux boxes, yes. So you don't really need any special hardware to set up a cluster. In fact, for testing purposes, it's quite appropriate to simply start all these processes on one single Linux box. They don't really have to be on dedicated machines if you just want to toy around with it, but then you don't have the redundancy that you probably want to achieve. Good point. In the early days, MySQL cluster was an in-memory database, so your entire tables had to fit in the memory, the total memory of the storage nodes. And this is a limitation that has been lifted in the meanwhile. So the latest versions of MySQL cluster can make use of local disk drives to store data, but the indexes that are needed still have to fit in memory. This is simply a requirement in order to be able to provide the low latency and fast response time the cluster gives you. How does the client pick the node of the cluster to talk to? It just talks with one, and then they internally make sure that you get the information. So if this one talks with that one, it knows who else to ask to retrieve the information. So this is transparent. The NDB API that is being used in the background takes care of this. A few more keywords here. So data is automatically being partitioned among the nodes. So you also have load balancing. The fragments are distributed, so you have multiple copies of the data. Failover happens automatically in a sub-second mode, so you don't really realize that a node has failed if you wouldn't get the notification by the logging. They can also automatically resynchronize, so if a node has failed due to a hardware failure, you replace the machine, you start this node up again, and it will register back into the cluster, retrieve the data, and will continue working without you doing anything. It's transparent, as I already said, to the application. It supports transactions. And I have some more info. We should continue. In-memory indexes I already mentioned. Big bummer. MySQL cluster is not suitable for any application. So if you think you can make Drupal highly available using MySQL cluster, think again. due to its nature, there are certain workloads and query patterns where MySQL cluster doesn't perform very well. Especially anything that has to join multiple tables together, or if you have to make range scans where you need the data from every single line of your table, because this requires a lot of communication between the nodes in the cluster. And that simply takes longer. Yes, it handles writes very well. In fact, much better than read queries. So if you need to pipe a lot of data into it, just use several MySQL servers and use all the inserts, deletes into the cluster using multiple nodes. So that is possible. And in fact, I have a slide that I wanted to show you here, if my clicker would work. So I think anything else has been said. Network latency is crucial. You can combine it with replication to set up a replicated cluster in another data center if you need it. Doesn't support foreign keys might be a gotcha. Here's a more elaborate picture. Again, here these are the storage nodes that you have, and this is really what MySQL cluster is all about. Then you have a small so-called management node, which takes care of configuring the cluster, but only at startup time. Once the data nodes have booted up, so to say, and they know their peers, you can even shut this thing down. This is a very small process that you can even install on one of the MySQL servers on top of that. So here in this example, we are using 3 MySQL servers to talk to the cluster. Something that's missing from this picture, you don't need MySQL for this. This cluster is fully autonomous, and you can use its own API to talk with cluster directly. So in a way, MySQL cluster is yet another NoSQL key value store with high availability that you can use. And we have, I think, a Java API and a Python API that you can use in your application to store and retrieve data from MySQL cluster without even using SQL if you want to. The question is if it's usually the case that you use a load balancer to distribute load. And sure, you could either configure the application to be aware that there are multiple MySQL servers, you use a load balancer to distribute the load. Everything's possible. Or down here? No. The MySQL servers here speak the so-called NDB API. So they too query the management server for the IP addresses of all the data nodes that are available. And then it depends on the data that you want to get, which of the nodes they are contacting. So you don't care about this. It's done automatically. Do the MySQL server instances have a query cache? Sure, you can use the query cache. Is it useful? Yes, it might, actually. It can be combined with the query cache if needed. And especially since joins and certain queries don't perform that well, the query cache might actually be beneficial here. So the question was, is it possible to use MySQL cluster as one big MySQL master server for replication? And that's exactly the case that I wanted to show you here. So cluster comes to parallelizing inserts particularly. So a colleague of mine came up with the idea, hey, how can this be combined with replication and making use of other storage engines to distribute the read load? And this is the picture that he came up with. So your application needs to be aware that reads and writes need to be split. You can use, for example, MySQL proxy or a load balancer that is MySQL aware for this. So any inserts go into this direction. You have 2 MySQL servers, and they use MySQL cluster to store the data and have synchronous replication. And then you set up a regular asynchronous MySQL replication stream that replicates to 1 or more MySQL servers that use regular storage engines. So up here, the data is highly available, stored in MySQL cluster, and it's then being replicated into normal MyISAM or InnoDB tables. And you can then run your queries that are more complex on this side of the story. So you have the best of both worlds. And that's a setup that has already been set up in production with some of our users. All right, another interesting approach to replication comes from a company named Codership, based in Finland, I guess, somewhere in Scandinavia. And they basically patched InnoDB to create a synchronous replication mechanism inside of InnoDB. And it can be used to provide both high availability, since the replication is synchronous among multiple MySQL servers, as well as high performance, since you can distribute the load between those machines. They are not using the classical schema of using two-phase commit protocol to make sure that the data is synchronized. They call it certificate-based replication. Their white paper is highly technical. I admit that I haven't understood it, but it seems to work quite impressively well. So Galera is something to keep a close eye on. They are very actively behind this thing. MMM, if you don't want to set up Pacemaker, you just have a MySQL setup that you want to make highly available. The MySQL Master Replication Manager is the tool to take a look at. It's a Perl script with a very active community that takes care of nothing than making sure that MySQL servers are in a replication configuration are being made highly available by moving a virtual IP address and making sure that the master-slave relationships are set up properly. So this is the smaller version, very dedicated and specialized to MySQL. Pacemaker really is the big gun that can do much more things. And it can also support read balancing, which is kind of nice. So if your application is capable to send read load to at a different IP address, MMM provides a floating IP address that can move between replication slaves based on which of these slaves is up to date. If one of the slaves is lagging behind, the IP address will move to another slave that is fully up to date, which is kind of neat. What happens if every slave has a big lag? I guess you can either configure MMM to give up in this case, or it picks the one with the lowest lag. That would be my wild guess, but I have to admit. Or it should go back to the master. Yeah, good point. If the master is still there, the virtual IP address would move to the master. Yes. How well does MMM handle split brain? It has functionality that makes use of an arbitrator, so I would guess that they have considered this case and should handle it gracefully. Cool stuff. I've seen webinars of this. It does a lot of the things that MySQL replication currently isn't capable of. There are more. Red Hat Cluster Suite is an application that does stuff pretty similar to what Pacemaker does, but with the blessing and support from Red Hat if you happen to use their Enterprise Linux edition. Enough said. Other operating systems have similar functionality. Solaris has OpenHA Cluster, which is the open source version of Solaris Cluster. This is really the big gun. Well, Solaris Enterprise Unix operating system. This thing is quite impressive, and they have a special MySQL plugin that you can use. So if you have Solaris in your data centers, this is the way to go. And well, not really an HA solution, but kind of nifty. Flipper is a little Perl script that allows you to switch master and slave by moving virtual IP addresses manually on the command line without having to configure the myCNF file manually and making the changes. Flipper does this for you in case you have no need for automatic high availability, but you just want to be able to switch between one MySQL server to another one for maintenance purposes as an administrator. So kind of neat. And with that, I'm finally through. More questions, comments, feedback. Okay. The best way to test failover of MySQL. What is the best way to test failover of MySQL? Well, at first you would have to set up an HA system like MMM to get started. And the best way, well, kill -9 would be one option, really to shoot the process with kill -9. Take the IP address offline, pull the cable, insert random data into the table files, change the routing table is also a good idea. There are various ways on how to trigger it. But for a basic test, just kill the process and see what happens. And use the manual system. Most of these failover systems usually have a manual trigger that you can use. If that one works as a first step, then you can start playing with killing stuff and destroying things. Any more questions? Otherwise, going once, going twice. Thank you very much.